Oh, welcome to Unit 4, which is quadratic equations. By the end of this unit, you'll be able to interpret and solve questions related to quadratic relations, and it's very similar to what we were doing in a previous unit, except it's going to have slightly different skills involved in it. And I know that I've met my learning goal if I can problem solve using the skills to create and solve problems that involve trinomial expressions. Just a quick review of what you should know before you do this lesson, which is to expand and simplify these things here, which are considered to be perfect squares. And at this point, I'd encourage you to pause and try and do them. Down below, I've got that these are the perfect squares expansion, and so I'm going to expand using the shortcut, which is x squared plus 2ab, in this case 2 times 2, which would be 4x, or 2 plus 2, because you could also expand this and use FOIL, plus 2 times x plus 2. 2 plus 2 is 4x, 2 times 2 is plus 4, and this here is equal to x minus 6 times x minus 6. This is equal to x squared, minus 6 is minus 12x, 6 times 6 is plus 36, and the negatives become positive because it's negative times a negative. Okay, moving forward, we're looking at maxima and minima of quadratic equations. The difference between quadratic expressions and equations is that an equation, you're probably going to be solving something. So our learning goals for this lesson will be to express a standard form quadratic equation into the form of vertex form, which is y equals a times x minus h squared plus k, by completing the square in situations involving no fractions. And we should, by the end of this lesson, be able to convert these expressions here into vertex form quadratic expressions. So here's what we were looking at over the past few units, and by the end of this unit, by the end of this lesson, you should be able to go from standard form to vertex form. And I'm going to show you how to do that by completing the squares. And it's also important to note here that this k value is the maximum, this h value is the x value of the vertex, and this a value hasn't changed regardless of which form you're looking at. And that's going to be important at least to know what the k value is, because it does say maxima or minima, and we're going to be asked to find the maximum or minimum. So just a quick recap, a perfect squares trinomial is a plus b squared or a minus b squared, and they could be expanded to these things here, and we're going to be using this in our lesson. So just to review, these were some expansions of perfect squares, and what I'd like for you to look at in particular is these numbers here. Is there a way that you could go backwards? How do you go from x plus 2 squared to get to these things? Or here's another question you could also think about. How do you go from this middle number to the last number? Can you go from 12 to get to 36? Can you go from 8 to get to 16? How do you go to get from 18 to get to 81? So sit there and think about it for a minute. Pause. And here's the answer. If I were to take 18 divided by 2 is equal to 9. So 9 squared is equal to 81. And that is the 81 that's happening right here. I've also got this one here, half of 8 divided by 2 squared. Well, 8 divided by 2 is equal to 4 squared, which is equal to 16, which is the number at the end. So what we start to see, if you remember the standard form equation, a squared plus ax squared plus bx plus c, then we know that if it's a perfect square, then c is equal to b over 2 squared. So getting into example 1, we have this convert the following to vertex form and state the optimum value. And what we need to look at is, what do we have to add to the end of this thing to make it a perfect square. And if we remember from our previous slide, it's half of this number squared. So just to do some rough work, 10 divided by 2 squared, half of 10 is 5. 5 times 5 is 25. So what we want to do is we want to add 25 to the end. But if we added 25 to the end of this thing, it would change it. So we actually have to subtract 25 at the same time. 25 minus 25 is 0, so it's like we did nothing. But here's what we can do. If we put a brackets on the outside of these three terms, then what you can notice is that this right here is actually going to be a perfect square. And that perfect square is going to be half of 10 is 5x plus 5 squared. 5 plus 5 is 10. 5 times 5 is 25. And then this minus 25 is still here. What you should have remembered from Unit 2 was that this value on the end is also the maximum or minimum. Outside here, it's a positive, so that means that the parabola opens upwards, and this is a minimum. So this is min minus 25. This over here, I encourage you to pause the video and see if you can do these two questions now, following the same idea. That should add a chance to try and practice. Half of 6 is 3. 3 times 3 is 9, so we're going to add 9, subtract 9. And if you wanted to see that, 6 over 2 squared is equal to 9, plus 9 minus 9. Put a brackets around the first three numbers. It's always going to be plus at the end, because whether it's a positive times a positive or a negative times a negative, that final number will always go positive, and outside the brackets will always be the negative number. This is going to be equal to, this is a perfect square of x plus 3 squared. That's the whole purpose, and that's why we call it completing a square. X plus 3 squared minus 9. This is again a positive, which means it opens upwards, and this is a min of minus 9. This here, we're going to take half of 10. So I'm going to try and do this a little bit quicker. Half of 10 is 5. 5 times 5 is 25. Plus 25 minus 25. Put a brackets around the first three terms. Half of minus 10 is minus 5. X minus 5 squared. This 25 stays, minus 25. This is, again, a minimum of minus 25. It's a minimum because the a value is positive. Even though you don't see it, it's like it's a positive 1. They get a little bit harder as we go, and that's why I wanted to spend a little bit more time in more complex questions. Here, it gets a little bit more complex. We can't just do half of 12 and then square it. We've got to take out the 2 by common factoring. So this is actually equal to 2 bracket x squared plus 12 divided by 2 is 6x. And we need to have that x by itself, the x squared by itself, in order to complete the squares. And now we can proceed like we used to, except whatever we do, it now has to go inside this brackets. So 6 over 2 squared means that's going to be half of 6 is 3. 3 times 3 is 9. So what we're going to do is inside the brackets, we're going to add and subtract 9 both at the same time. X squared plus 6x plus 9 minus 9. And actually what happens is this 2 is going to multiply this minus 9. And it's going to come out 2 bracket x squared plus 6x plus 9. 2 times the minus 9 turns into minus 18. And notice that this trinomial here is a perfect square, which is just x plus 3 squared. So this whole thing is going to be equal to 2 bracket, where's my pen? Bracket x plus 3 squared minus 18. And this is, again, this number out front is a positive number, so this here is going to be a minimum minus 18. So min minus 18. This next example, we have to pull out the minus 4, common factor it. X squared plus 2x We only factor the first two terms. And now we have to add and subtract something to make this a perfect square. Half of 2 is 1. 1 squared is 1. So this is going to be equal to minus 4 bracket x squared plus 2x plus 1 minus 1. We want to multiply the 4 times the minus 1 at the end. That's equal to minus 4 bracket x squared plus 2x plus 1. Minus 4 times plus 1 is plus 4. This trinomial is a perfect square, which is x plus 1. Minus 4 x squared. Oh, we don't want the squared there. That is x plus 1 squared, because half of 2 is 1, and 1 times 1 is 1, plus 4. So this number on the front is a negative, which means that the parabola opens downwards. This is a maximum of positive 4. Max positive 4. Encourage you to pause and try and do this one on your own. We factor out the minus 3. This turns into x squared minus 4x. This is equal to half of 4, and squared is going to be 4 minus 3x squared minus 4x plus 4 minus 4. This is going to turn into minus 3 times x. We could probably skip one step, minus 2x squared, because we know that this thing here is a perfect square, which is what we're getting to get this one. And this minus 3 times minus 4 turns into plus 12 when it comes outside the brackets. So this is a negative, which means it opens downwards. This is a maximum of 12. Turn to our final questions, which are the same as what we've been doing before, except we've got this last term. And it is a little bit more tricky because we're actually going to factor out the 2 only from the first two terms, not all 3. And that's where a lot of students will get confused. So we take out or common factor the 2 from the 2 and the 8. That becomes x squared plus 4x. And on the outside, this 19 stays there. And what we want to do is we want to make this a perfect square. And we can do that by taking half of 4, which is 2, and squaring it, which turns into 4. So we add 4, subtract 4 inside the brackets. It must go inside in order for this to become a perfect square. X squared plus 4x plus 4 minus 4. And this plus 19 stays on the outside. But when we finally finish things off, this thing here is going to become the perfect square. And this 2 is going to multiply the minus 4. It will come on the outside of the brackets. So what this turns into is 2 brackets x squared plus 4x plus 4. The minus 4 comes out, times by the 2 becomes minus 8 plus 19. This is equal to, this thing here is a perfect square. So this is 2 bracket, that becomes x plus 2 squared, half of 4 is 2. 19 minus 8 is going to be plus 11. This is a positive, so this is a minimum of 11. Factor out the negative 3. X squared plus 4x. We do not factor out the last one, minus 60. We want to complete the squares here. Minus 3x squared plus 4x plus 4 minus 4 bracket minus 60. This one right here we're going to do in one final step, which is going to turn that into minus 3. That's an x plus 2 squared. We're going to take out the minus 3 times the minus 4 turns into plus 12. Minus 60 is equal to minus 3 x plus 2 squared minus 48. And that is a maximum. I wish I could have a bit more time to explain, but this is your homework. Thanks for watching. Practice will make perfect. Do your best.